Hello. Hope you are all fine. So today we're going to see something under the CDACC. So this is the new curriculum that is being implemented by the government. So the curriculum is quite fine. So it involves a lot of practices. So all the things that we were doing under the next series, we will be doing them under the practical CDACC curriculum, and more so the new modularized CBET curriculum. So that was implemented earlier this term. So this is a question that was done early on the year, and even some series for the November practicals under the survey, generally survey section. So that is land survey, building, civil quantity. So anything that has a relationship of survey, we are going to tackle that. So that is what we are going to be looking for. So feel welcome. Everything that we'll be doing will be more of in calculation, and then what we are doing here in calculation is what we have already done during the practical activities. So I hope in your college you are well equipped with some of the tools, and you can repeat this practical on your own. So when it comes to the actual exam, you can do at least something that is more of serious. So this is chain survey practical under the CDACC curriculum. So this question can be applied in variety, even in the preliminary sections found in building. They can bring such a question in land survey, in even construction survey level 4, civil engineering level 6. So welcome, feel at home. This is Gedgera Steven from Matili Technical. So before we go on, so at the institute we have introduced an distance learning. So the Odell e-learning, you can register through the portal. So you can go directly to the link that I have displayed here, Matili Technical at ac.ke. You log in, then you apply for the Odell. So more of this is the same similar thing. You can learn in a distance setup and get certified. So remember, visit the website and you can get a lot of information. Also, physical admissions are always on. Feel free to come and join us and enjoy the CDACC activate way, where we are embracing the practical that is applied on the daily activities and the industry. So feel free to do that. I'm going directly to the question. So the question from the paper. So the instruction to the candidate: you are required to perform the following task. The first thing is to establish a baseline AB on the field provided. Then you are to carry out chain surveying. Make sure you obtain 2 obstacles on each side using offsetting method. After which you are going to record the observation in the field notebook or the full scopes provided to you by the institution or even you. Then later you plot and transfer the positions of the obstacles on the baseline. Finally, you calculate the area of the figure formed. So under the tools and equipments, you are required to have a cross staff or a builder's line. In most cases, the builder's line is commonly in all our institution. Then a 30-meter tape or even a 50-meter tape, in accordance to the area that you have allocated for your practical. The scale rule is for the final drawings. So most In most cases, these two are the importance of the tape and even the builder square. So this for offsetting, so you offset something that is 90 degrees. Then the pegs are used for locating the control points. Then the drawing paper, you'll use it later for your drawings, and the field notebook is for simple calculations that you're going to be putting down in order for you to finally do the work. So this is the practical exercise that we did with our trainees in the institute. So this is a tape, steel band, or even the normal tape, but it should be of high, let's say high quality, in order for you to minimize the area of expansion and contraction brought upon by the steel tapes, the cheap ones. These the pegs that you're going to be using to allocate the points. So this is the field work that we did. This is a survey index sketch. So from A to B, so we started here. So from B to A, at changes of interval, so you're supposed to get at least something where you can offset your data. So from A to B, we chose 120 meters, quite huge. So if your institute has enough land, you can do that and get more accurate points. You can reduce that to 30, but that will be limiting you to calculations and more of errors brought upon. So from B, so here is the first this is the first point where we offset our chain. So this is the baseline. So this is the baseline that we first establish. So first of all, you put here a peg. You again locate the other mark, you put a peg. In our case, I like to use a string, so I tie a string here at B to A, so that I can have a uniform baseline that is not interfered by any movement. So some use tape, but to me that kind of arrangement brings upon wear and tear of the chain, leaving it on the grass for a very long time. Someone can even step upon it. So I simply use a builder's line from B to A. Then we measure using a tape. So from 0 to 20, this is a chainage. So we located, let's say here is a tree. So you locate here a tree here, you offset that. Then the distance covered from the baseline to where your tree is 4.96 meters. So that is the offset there. Then again at this distance of chainage 30, we locate another item. So you can have another building here, you offset it. So the offset distance is 11.75 meters. And then you move on to a chainage of 60. Again here you can find maybe a manhole, you offset that manhole. So after offsetting the offset distance, so these offsets will be that will be 8.92 meters. Again you move on to the last point, you offset. So here you can have maybe a pile of rocks or even a heap of sand, so you can offset again there, or even a building, a tree, so something that you can be using for reference. When you offset that, you get 5.6 meters. So those are the offsets. So we were told to locate at least 2 offsets at either sides. So this is 1, 2. Again here we have 1 and 2. So here this is a field work survey. So you, by locating them, you make sure you put the pegs in order for you to have more accurate calculations. So by doing that, everything will be fine. Again, After doing that, you are supposed to calculate the area. So here you have been told, so you establish the baseline AB. After establishing the baseline AB, you carry out, so we have identified 2 obstacles on each side, a total of 4. So we are going, I have already plotted because this is an already practical that we undertook in our normal classes. So the classes have been emphasized to be more practical based and assessments to be given at a regular interval. So the last thing here, we're going to calculate the area of the figure formed. So the simplest ways here, we have a formation of, so here we have a triangle, again here we have a triangle, here we have a trapezium, then also here we have a trapezium, then the remaining 2 here, this is a triangle and the last one is a triangle. So here we have a formation of 6 different figures forming the total area. You can simplify this. You can do the area normal, the area of a triangle, I have base times height. You calculate for the triangle, then the trapezium also you can do the same. I have a plus b times height, these areas of the trapezium, and then the total area you can sum them up. But in this question, just like I used to remind the students, so this thing, these calculations were done during the high school eras. We can calculate the area of such a figure using a table, and that is what I'm going to be doing. So on the table, you can have a column for the figure that is formed on there, the changes, the base, then the offsets that we have calculated from the diagram here. So there are the offsets, then you find the mean of the offsets, then lastly you calculate the area. So here on the first one, on the first figure, BJF, so BJF here we have a formation of a triangle. So that triangle is at a chainage of 0 to 20. So this chainage here, so it's 0 to 20, then the offset is 4.96. so that is the offset there. So the mean offset is the offset that we have here divided by 2. So it's the only offset found there, so we directly divide it by 2, getting 2.48. then the area, you multiply the distance covered, so the base times the mean offset, and you get the area there as 49.6. so that is similar to half base times height, because these where our height is and we have already divided it by 2. So similar working, just like what we are having here on the table. And then on the second area, BH2, so the second area here, BHC, so BHC here, we have a change of 0 to this is 30, then the offset is at 11.75 meters, and that is the information that we are bringing it here on the table. So this is the chainage, the base is the distance covered, and then the offset, we only have one offset. So by dividing this offset, the mean, so dividing by 2, you will get 5.875, then 5.875 multiplied by the base, you get the area here as 176.3 5. Then we go on to the third figure here. So the third figure found here. So this is a trapezium. So FESJ. So it has two offsets, 4.96 and 8.92. Then it is at offset 20 to 60. That means the distance covered in between here is 40. So you subtract there direct. So this is the information here. So the change is 20 to 40. That is the base covered. Then it has two offsets here. So the two offsets here and here. So those two offsets, you're going to add them, then divide by 2. So by adding them and dividing them by 2, you get 6.94. Just like the symbol of trapezium, a half into a plus b times h. So a half a plus b, here we have a plus b already. So you get 6.94 multiplied by the base, you get the total area as 277.6. And then again we move on to the fourth. So also here we have a trapezium covering from chain edge 30 to 90, having two offsets, 11.75 and 5.6 here. So those two offsets, those are what we are going to be using. So the distance covered in between, so 30 to 90, that is 60. The two offsets are displaced here. So this is a trapezium. So the formulas for finding that. So here's the distance covered, the base 60, the two offsets. So the mean of the two offsets, you add the two offset and then you divide by 2, getting 8.675. That mean offset is multiplied by the base here 60, getting a total of 520.5 meters. Then we move on to the last two triangles. So under area 5, the AGD. So the chain edge covering that area is from 90 to 120 here, and then it has one offset of 5.6. So that is the information that we transfer here. The distance covered, so from 90 to 120, that is 30 meters. The offset is 5.6. The mean of the offset, so divide 5.6 divided by 2, you get 2.8. 2.8 multiplied by 30, you get 84.00. Lastly, the last area covering from here, so that is ASE. This is the offset that is covered from chain edge 60 to 120. So chain edge 60 to 120, that is the information that we bring in this table. And then the distance covered in between the 60, it has only one offset. The mean of that, you divide by 2, you get 4.46. 4.46 multiplied by 60, you get 267.6. So this is the table format of calculating chain edges from an area of such a figure, which we have formed during the exercises of the practical conducted on the field. So finally you go and sum up all these areas using a calculator in order to get the total area that is needed to be covered. So you add every area here, so all are in positive. You add them, getting a total of, so the total area is 1375.55. So this is the total area meters. square. Remember that. So let's go directly to the checklist. The checklist that were found. So first of all, you were supposed to wear the PPEs. You get 2 marks. Establish the baseline AB, you get 3 marks. Form the triangle. So we have 2 triangles, each form that. So we have 2 triangles at A, 2 triangles at B, so you get 2 marks. So those 2 triangles, so these 1, 2, and also 6 and 5, so those are the triangles formed here. And then change the offset, the first offset, second offset, third offset, fourth offset, so each 2 marks. So here we did that, so we have an offset there, an offset, and off, so we have a total of 4 offsets there. You get your full marks. We move on to the next. You record the observation in the field notebook. So the data for the first, the second, the third offsets. So you record the distance covered on the offsets there. Then formation of a regular and irregular shapes. We did that, so we have formed the regular and irregular shapes. And then you plot the points on the graph paper. So correct plotting, you get 6 marks. And you remember the rules of drawing on a graph paper, including the title and the scaling, so that's a full 6 marks. Then you calculate the area using, so prepare the table, so you get the marks. So and then you tabulate the base, we have done. You tabulate the mean offsets, we did that. You calculate the area of 6 points, we have done that. And finally you get the total area of the points, and you allocated all the marks there, and then you'll be good to go. So remember to subscribe to the channel. I'll be starting the CDACC way, so I'll be demonstrating the practicals that you'll be doing. I'll be getting those CDACC already done assessments, then I will be showing how you can best do them on the field, the solutions, and even the best. So thank you, CDACC. So remember, modular is the only way, and practical based assessment, and what is needed in the field is what we are more emphasizing in. So remember that, and you can ask any question through my email found on the channel. So remember to subscribe in order for you to get more assessments, more solutions that will be coming on your way. Thank you, all of you, for the great support that you have also been giving me, and also the gift of life. Thank you.